Hello, everyone. FARABI here. Going to be talking about the dedication and acknowledgement part of our report before we begin um, going into any of the parts of the project. So, going into this quickly, first and foremost, we really want to show our gratitude towards our lecturer, Dr. Haliza, for essentially teaching us throughout the semester, giving us all the help we need, all the aid, and essentially guiding us towards our path to completing this project. Because throughout the semester, we've been constantly helped by Dr. Hausa with beneficial resources to help kind of strengthen our knowledge of digital logic, essentially. And throughout kind of learning everything, this project was made to be very possible. And this project basically helps put all the knowledge that we learned into play. And that's why we're very much greatly appreciative of Dr. Hausa for making our journey very easy and simple to follow. Another part of the acknowledgement that we want to kind of emphasize here is the tools we used. So a part of our project, one thing that we used and in order to create our integrated circuits is the app, which is titled Digital Electronics Deeds Application. So this was a tool that all the students were asked to install to kind of use and familiarize themselves at the start of the semester by our lecturer, Dr. Haliza, to essentially help us practice, creating these circuits and getting to know the familiars, kind of functions, the tools of the apps, and as a way to show kind of our acknowledgement, we just want to say thank you once again to this beautiful resource that we've been given by our lecturer, and essentially we've practiced it throughout the entire course, and it's basically centered it's cemented our ability to kind of take what we learned from class and all these lectures we do and put them into a practical application. The entire process of us getting familiar with all the difficult learning curve that might come with digital logic, it's basically been eased out by Dr. Haza, since she's prepared us for the learning curve that would come with learning digital logic. And essentially throughout the course, we've had several assignments and tasks that were set in different points of the course in different weeks to kind of help us practice and keep our ability to use the app refined and clean. And essentially, we all believe that without this constant stream of help from our lecturer, we'd find it very difficult to formulate this project. And one last part is we'd like to also kind of say a big thank you in terms of everything that we've been provided in our learning path. Essentially, without them, the level of how clear things are, how easy it'd be going into this project would be very much different. So that's why we're just very much thankful for everything that we were given to basically learn in this course and apply everything for this project.
Hi and Assalamualaikum. My name is ALYA binti HUZAIMY and today I will begin my presentation of my digital logic project. So let's start with the background of this project. By displaying the number of parking spaces that are available, the digital parking controller helps to reduce the amount of daily parking commotion. Additionally, the use of this controller will greatly reduce the traffic jam caused by people overparking in their parking spaces, which can cause traffic delays. In public places like university, mosque, condominium, and crowded area amongst others, this controller may be a great of use. So the problem that we can come out in this situation is during the weekend and holidays, parking lot at supermarket tends to be congested. As a result of the current pandemic, it is becoming increasingly difficult for people to purchase essential in the crowded places. Because of these viruses are keep on spreading, it will only get worse if we will not avoiding it. In addition, many parking lot will be completely full on weekend and holiday due to the high volume of visitors. People will have difficult time to find parking spot. As a result, traffic jam and other inconvenience can be avoided if drivers are given advance notice and warning before entering the parking lot. That's all from me. Thank you.
Hello, hi there. My name is Muhammad Hakim bin Osman, and now we'll be discussing the solution for the parking space problem for this project. We have discussed the solution among the teammates, and we took solution which is you can see here in the report. So the first solution is a parking space counter. So this parking space counter is act as a counting system. They can provide initial information to the user. So if they know the number of parking spot that available in the compound, so they make them easier faster for them to find a parking spot in the compound of the supermarket. So next is the full or not full display of parking space. So if they know, if we have this display on the entrance of the compound of supermarket for the parking space, so it will be like a vital information for them to know whether go into the compound to park their car or they can just park outside at the compounds. So it will give them like a make them lesser time to make decision for them to park their car. So that's the two solution for this parking space problem. Next, we will go to the block diagram that have been drawn by us. So as you can see here, this is the block diagram for the parking spot. So you can see we have like one bit input here. So one bit input here will represent it will represent the number of parking space that have in the compound. So it will act as a sensor, and this sensor will give a signal to the full adder, which is the full adder will be like the sum up the number of parking space that available at that time. So it will go to the 4-bit adder and will be compared with the comparator, and then it will go to the counter display, which is it will give the number and number of display on how many available parking there are in the compound. So next we have the counting circuit, which is the counter for the number of vehicle that enter the compound of the supermarket. So now you can see that if they have a vehicle enter the compound of the supermarket, it will be counted as 1, 2, 3, and so on, and it go to the comparator and will be displayed the vehicle in the compound is full or not. Okay. So with these two block diagram, we have been discussed together which part of the component that need to have in the design DIT circuit. We have divided into two groups, two part, which is part A, part B. Part A is for the component for act as a combination circuit, and the part B as the sequential circuit. So part A, we identify that we need to have three component that acts as a vital component in the DITs, which is the adder, basic gate, and comparator. Same goes to the part B, which is sequential circuit. So the clock, we need to have clock and JK flip-flop as the sequential circuit for the car counter in the DIT simulator afterwards. So yeah, I think that's all for the solution part. Thank you.
Assalamualaikum and hi, my name is Misha from Group 3. My group mates are ALYA, Harith and Al-Farabi. In this video, I will demonstrate the process part of our car park project. For this parking slot system, there are two floors, basement 1, basement 2. And it also consists of counter for basement 1 and counter for basement 2. And the last spot display for full or not full display. Each segment in basement 1 will be connected to two full adder, LEDs, 4-bit adder, comparator, and 4-bit segment display. Now I will run the Dit Simulation Circuit and go through according to situations given. For situation 1, there are 3 cars in segment A, 3 cars in segment A, and 5 cars in segment B. This shows that the number of cars in segment A is less than the number of cars in segment B. Therefore, the comparator will display 1 at A is less than B. Hence, a total of 8 LEDs will light up to indicate 8 cars parked in basement 1, and will display 5 in segment B and display 3 in segment A using 4-bit segment display. This is to indicate the number of car parked at parking spot by using 4-bit segment display. For situation 2, it is vice versa for situation 1. If the number of cars in segment A is more than the number of cars in segment B, the comparator will display 1 at A is greater than B. Moving on to situation 3, if both segments are full, the comparator will display 1 at A is equal to B. Hence, a total of 12 LEDs will light up to show that the basement 1 for both segments is fully occupied. While nothing changes at the last display board because basement 2 is not fully occupied yet. 0 will remain as the output. For the last situation, if both floors are full, the last display board will display F to indicate parking slots are full inside a building. Meanwhile, for part B, using sequence counter, it consists of two counters that are connected to a display board using 4-bit segment display in each segment. This sequence counter clock will trigger if a car enters the building. The first counter for basement 1, the second counter for basement 2. Therefore, the counter will start counting cars. The number of cars will be displayed in binary numbers, but it will be shown as decimal numbers on the display board by using a 4-bit segment display. So that's all from our group. Thank you.
Okay, and now we're at the ending rounds of our project video, and I'll be giving you a rundown of the conclusion of our report. So as a whole, for all of us, this project has been one that was very eye-opening, and it's basically tested our abilities to take the things the theoretical concepts we learn in class from our lecturer, Dr. Haliza, in digital logic, and we basically are applying them to this real-life simulated scenario that is very much evident in the real world, and it's both practical and systematic. So from the very start, I think the main thing that we've had to do is identify one of the types of the system controllers that we wanted to pick in real life. And one thing that we decided on was that we choose the car park controller. And we chose essentially it's because we chose the one that proved to be the most useful and could actually tackle a real life scenario in this case. And early on in the process, that's essentially what we did. We were able to identify the problem that our system controller could effectively patch up and fix, and which was to reduce the rates of daily parking commotions in areas that are have a lot of people in it, are very concentrated in the population, both in the people and actually the vehicles themselves. So we're able to design this car park controller that would essentially help utilize this function and this tool to find access to empty spaces quickly and in crowded spaces in parking lots, and wouldn't be something that you needed great understanding of digital logic to use. It'd be very easy and very quick to use. So breaking down the controller itself came into play when we essentially had to figure out the components of the controller itself. When we're making this thing, we need to understand the bare bones of what's going on with our circuits and everything. And when we're constructing the inputs and the outputs and all the process of the controllers, we needed to know what these could account for. I'll give you a quick example. I don't want to rephrase too much of what we said before. For essentially, we applied a switch onto the controller, essentially to act as the sensor system. And with certain values, it would kind of output a result to a certain number used to represent the thing that it would output of whether or not a specific parking lot is crowded or empty. And I guess reflectively, one thing that we kind of spoke as a group was that we've been delighted to kind of been able to complete the project as a team, because as students, we're able to take away important skills from this project. For example, being able to take the things we learn in class and then put it into a practical project. This is something that we all believe is very important, because not only does that mean that you are able to understand the things that are going on in class, but that means you can actually apply it. And that's why we're kind of saying that it ultimately shows that you're able to go beyond just simply learning, and basically you're able to create something meaningful and useful. And there are other parts of the project that had different difficulty ratings in our opinions. For example, we found that in the foundations part, and being able to solidify the fundamentals of our project, we were able to work well as a team. And in the early stages, we recognized which system controller we wanted to work for, and break down the reasons why we wanted to do it. distributing the work amongst each other was very key for us, and it went very successfully. As throughout the project, we kept communicating with each other. If something needed help, we'd go here. Something um, was kind of needing some patch up, we'd do this. If something was complete, we'd communicate with each other, and keeping everything clear very much stopped any cloudy messes going on with our project. One of the difficulties that we agreed on that we faced throughout finalizing the project was actually completing the integration of our system controller. It was more so a task that proved to be difficult in terms of time, as it needed a lot of revision to do, kind of going in and out about to see which one looks neater, kind of redoing it to make it look nicer. But yeah, we were able to complete the project in the end, essentially. And for future advancements, we kind of spoke about how what we would do differently if we had this project again. So in the future, the besides the addition of like LED and board display, our group kind of agreed to level up the project by adding a virtual assistant voice, like Siri, to help people remember the parking section names. Because most people kind of tend to struggle remembering the parking spaces names when they're in a rush or when they're in a time crunch. So with this feature itself, more people are able to go anywhere without worrying about forgetting a specific section of a car park. And we kind of just hope that this project can help smooth the journey for everyone who's out there looking for a parking space to go to. And other parts of improvements that we kind of spoke about was that if we would approach it again, we'd like to see an extra mile towards the kind of design part. And although we did complete it, what we mean by this is to have kind of a more graphical design that represents a car park controller more, to have more realistic elements. And we just feel that it'd be kind of the next step that we wanted to approach. And we think that taking the circuit integration that we created and placing it to, as I said, a real controller that's graphically designed would be the step we take to fully translate our this integration into reality. That's all from me.
Assalamualaikum and hi, my name is MISYA SYAFIQAH and I will continue the last content of this report, which is list of appendices. It consists of 3 parts. Appendix A is task distribution among members, Appendix B is the photos of group discussions, and Appendix C is the advanced features added in our project. In the beginning of this project, our group decided to divide the tasks according to pairs, ALYA and Harith, while me and FARABI. ALYA and Harith identify problems in car park system, determine the suitable combinational logic circuits for use in a parking system, create a list of backdrop ideas, solve challenges in accordance with project specifications, make a sketch of Dit circuit, and brainstorm idea for advanced feature in part A and part B. For our part, we schedule and handle for group meetings, provide details and gather information for advanced feature in part A and part B, complete the report content in accordance with the format using APA format, lastly, create a video explanation of the Dit circuit. Moving on to Appendix B, here are the photos that was taken during meetings and during pair discussions. Last but not least, Appendix C is the advanced feature added in this project. So this is an example of LED as an indicator if a car has occupied the space. Then this will be the example of the board that will indicate availability of car spaces. And this is the special feature for this project, which is using voice assistant like Siri or Cortana. The function of this feature is to help people remember their parking spaces name. We hope this feature can solve many problems related to parking system. Again, we hope there will be a chance to make this project into a reality. So that is all from Group 3. Thank you.